most of the challenges in a placement line occur at the end-of-line machine. We'll explore how we can handle these challenges. Welcome to the show.
Welcome to the Facts on Open Automation show. We are talking today about bottlenecks and what open automation solutions a placement equipment should possess to overcome bottlenecks. What is bottleneck? What is a bottleneck? It's a point in your production which operates at lower capacity than all the other points. Some common reasons for bottlenecks are either machine capacity or capability, a poor communication, poor process, or a human resource shortfall, or simply lack of automation. Just to recap, what is an open automation solution? It's a flexible solution which you can gradually build into your production line and which you should only build in if it makes sense for you, of course. I can feel already your first question. Who is with me in the studio to discuss this topic? And I'm glad you asked this. And I'm glad also to introduce, first of all, Mr. Yetula Avdili. Hello.
Hello, Laszlo.
And Mr. Wolfgang Eisner. Hello.
Hello, Laszlo.
Yetula, according to your experience, what is the cause of bottlenecks nowadays in electronics manufacturing?
Well, Laszlo, about 90% of the placement content have to be covered or is covered by the first placement machines in the line, while only 10% of the placement content is covered by the end-of-line machine. However, according to my knowledge, 90 to 95% of the most complex components have to be covered by the end-of-line machine. So the question is why it is so. And here are some reasons. First, these components are heavy, they are big, they are tall. They are supplied in different packages, and it's really hard to find the appropriate process settings in order to place this kind of components in a reliable way. So in a nutshell, we are talking about O-chip components with a high degree of complexity.
Do you have an example for us for this?
Yes, Laszlo. I have brought one connector with me. It's a very tall one. It's 50 millimeter tall. It can't be picked up with a vacuum nozzle due to the pickup surface, so we had to design a dedicated gripper for it. And the next challenge are the pins. So we need to make sure that we can distinguish between bent pins and straight pins, and we need to make sure that we can inspect also the right pin length in order to place this component in a reliable way.
I understand. But in total, it means component diversity is a reason for bottlenecks in the electronics manufacturing.
Absolutely, Laszlo.
By the way, why do you call it end-of-line machine?
Well, it is not the last machine in the SMT line, but since we are talking from our perspective as a placement machine supplier, it is the last placement machine in the SMT line. And that's the reason why we call it the end-of-line machine.
I'm glad you mentioned from our view as a machine supplier. Thanks for your opinion. But I wanted to know also the opinion of a real user. And that's why I was happy to interview yesterday Mr. Wojciech Torzinski from Polish EMS supplier Printor about his opinion regarding challenges on the placement line. Welcome to the Facts on Open Automation show, Mr. Torzinski. I'm very glad that you joined us. Can you briefly describe your EMS company Printor from Poland?
Hello, Laszlo. Printor is a family business with over 40 years of tradition in the electronic manufacturing. And we are located in the very center of Poland with our own PCB shop in-house. And currently we are employing 120 people and still growing. Our focus has always been on high reliability and delivered products. At the same time, we specialize in small and medium batch production. So we aim to deliver always on time in full. And these productions are mainly medical, industrial, and audio segments. Our strategy is stable growth with customers that require this high quality and due date performance, including testing and final assemblies. Therefore, our customers are both global companies and also niche and highly specialized equipment manufacturers.
So Printor, a highly flexible EMS company in Poland. What are some of your challenges in your placement process?
Well, I would go in two directions here. The most recent one is related to the component shortages, because reduced availability of components force us and our customers to take up decisions about alternative component usage. Luckily, the ASM placement platform has the alternative components function that allows to make the changes in the setup in a very efficient way. So this is a big help in this current challenge. Another aspect of the same problem of component availability is that the packaging of materials is frequently changing. So sometimes we can receive the same component packaged in different form. And here also some of the features offered by SIPLACE help us to make auto corrections, placement, and this is also a strong point here. But I would say that the more global and long-term trend is that components become more and more integrated. So we come across much more big and also various shape components. So here I would say that the odd shape component function is one of the very particular functions that helps us to deal with non-rectangular components and also high components that are more and more frequently used.
Interesting. We discussed material issues also in our last show. Then can you tell us what were your top reasons to choose ASMPT solutions?
So here I have mentioned that we were entering the medical industry quite strongly with a very particular project that was using some micro BGAs assembled on flex circuits. So it was a quite demanding product. And here we put our criteria of choice in the process from base printing until placement was the key point. We have a good beginning of the process. And here the process expert and deck integration was one of the best solutions that were available, and ASMPT was the only one at the time that could meet all our requirements. Yes, and secondly, also the material tracking is another important factor for the traceability purposes. And here also the SPLICE sensors are another, let's say, nice feature that also supports our control over the quality in the placement process.
Wojciech Torzyński from Printor Poland, thanks for your insights and thanks for joining us.
Thank you very much.
You will find more information about Printor in the info corner, which is at the top right corner of your screen. By the way, you will also find more information about our last show, which also handles strange packaging situations that's similar to what Mr. Torzyński explained in his interview. So, Jetula, I guess what Mr. Torzyński said just confirms your opinion.
Absolutely. I absolutely agree with his statements. Almost everyone is facing similar challenges in the end-of-line area, Laszlo.
So we understand now the situation at the end-of-line machine, the stress there. Are there trends in electronics manufacturing which even increase this bottleneck situation?
Yeah. In a nutshell, the trend is automation. So previously, manually placed components shall be placed now on a standard SMT machine. So that's the trend. The reasons why this kind of components have been placed manually are the following: size, they are out of the machine specification, or they were out of the machine specification. Weight, they are also out of the machine specification. Vision system, they couldn't be recognized in a proper way. And Laszlo, since the trend is your friend, we have worked on several solutions and can cover all these challenges with our products nowadays.
Wolfgang, it's kind of ironic that you are here because you are the head of special applications. Your job is to design special purpose machines, yet we recommend general purpose machines instead of special purpose machines for such challenges. Why?
Well, Laszlo, there are different ways how to handle those components or processes. One is, of course, to use a dedicated, customized robot cell. This robot cell but has also its disadvantages. It is highly dedicated and ideal for a specific process or component. However, to modify it in a way that it can handle other components or other processes is usually difficult or even impossible. And this looks completely different when using standard SMT equipment for this one. Our machines, for example, can handle very large components, very heavy components, tall components, also high placement forces, but you can still also handle special feeders and processes like clinching. However, it's still a standard SMT machine and can therefore also still place standard SMT components. And beside that, it is still offering all the standard functionality like digital vision, setup verification, traceability, up to all of the automatization features we offer.
So, Jetula, what capabilities should such an end-of-line placement machine possess?
Laszlo, this is a very good question. We have prepared a short movie together with my colleague, Ms. Petra Klein-Gunnewig, and we would like to show you this movie that might answer your questions. So let's have a look. Let's get started. Although the end-of-line machine has to cover a relatively small portion of the placement content, it has to cover the most complex components in the line. These components are often big, they are heavy, they are tall, they are supplied in different packages, and sometimes also very challenging for the vision system. So what does an end-of-line machine need to cover all these requirements? Maximum feeder space. Since the components might be very big, they might occupy also a lot of feeder slots. A head which is capable to handle all these different components, all these big components, heavy components, and tall components. And a head which is capable to apply different placement forces and still to be able to be very accurate. A machine which is capable to handle different packages like trays, like sticks, like tubes. And at the end, a vision system which is capable to handle all these different O-chip components. The very high force twin head can handle components up to 200 mm by 110 mm. The maximum component weight is up to 300 grams and the maximum component height is 50 mm. The placement forces can be adjusted from 2 Newton up to 100 Newton. And the placement accuracy in combination with a very high force twin head is 25 microns at 3 sigma. In addition to that, the very high force twin head is able to detect whether components with board locks have snapped in or not.
Placing large connectors, heavy components, or components with snap-in requires an exact support of the PCB. Placing pins manually is no real choice, especially for small lot sizes. With the option Smart Pin Support for all SIPLACE placement machines, we can ensure an exact support of the PCB. The programming is done quick and easy with the wizard of SIPLACE Pro. When downloading a new program, the pins are placed automatically to the correct position.
When a product changeover occurs, very often the changeover tables have to be replaced. In order to avoid that the end-of-line machine is becoming here the bottleneck, we have even a movable CUT30 which is beside the WPC. So the movable CUT30 can be replaced and exchanged very easy and very quickly.
Placing components with through-hole connections requires a highly capable vision system. Not only the pins, but also the alignment pins must be recognized. These pins often have the same color as the main body, which is nearly an impossible task for classical 2D camera systems. With the stereo measurement of all SIPLACE placement machine, this can be done easily. 2 pictures are taken with a precise distance. The pictures are overlaid, and with the 3D image, now all pins can be recognized precisely. In most cases, the last machine off the line needs to handle baffle trays of all kind and heights. With the new tray unit for SIPLACE TX, this is an easy task. The tray unit can handle 2 JEDEC trays on a tray carrier or a large tray with a size of 355 by 275 millimeter. Up to 60 JEDEC trays can be stored in the main tower. In the cache unit, 24 JEDEC trays can be stored. An easy refill is possible with the automatic refill unit, allowing to exchange trays without stopping the machine.
You can experience more on the features Jetula and Petra explained through a remote demonstration. Just contact your friendly ASMPT account manager to organize one. Jetula, I understand the SIPLACE TX is our super fast and compact machine, but what about those end-of-line capabilities of that machine?
Right, Laszlo. Recently, we have enhanced the end-of-line capabilities of the SIPLACE TX machine. As you have seen in the short movie, we have released the SIPLACE tray unit in combination with the SIPLACE TX machine, and we have added a second stationary camera in combination with the SIPLACE TX machine. So that means now we are able to increase the loading capacity of wider feeders and wider components within the SIPLACE TX machine, which is very important for the end-of-line machine.
I see. I mentioned at the beginning the human factor. Do you have examples for bottlenecks due to the human factor?
Yes, I would name here 2 features out of many. First one is the pin 1 recognition from the top side of the component. As you know, our customers, they do have different suppliers for the same component. Now, supplier A might supply these components with a pin 1 at 0 degree and supplier B with a pin 1 at 90 degree. And this might lead in the production to quality errors, to misplacement. In order to release the operator from this task, we have automated this task completely. For instance, when the feeder detects a new reel due to the splice detector, due to the splice detection, the system automatically will check the pin 1 of the component and pick up the component and place it at the right angle. The second feature is the automatic illumination setting. What we have seen in the past is because of the increasing complexity of this kind of components, operators and technicians were really struggling to find the right illumination settings for this kind of O-chip components. And also here, we have completely released the operators. We have completely automated this process. Now our vision system can automatically look, search for the best illumination settings for this kind of components.
Yes, Jetula, and don't forget the automatic acceleration optimization function. Maybe first to the background, Laszlo. Customers, the operators and engineers at customer sites today have very little time for experimenting and for finding the ideal settings. Unfortunately, then they tend to set the acceleration very low, which leads to a very low line output. And this is where the automatic acceleration optimization function comes into place. This function can be easily started by operator or engineer at the machine. The machine will then pick up the component. It will start to move it with a very low acceleration, and parallel to increasing the acceleration, it will take pictures of the component with the component cameras to ensure that the component is well fixed on the head. And like this, automatically and also extremely quick, the machine can determine the ideal balance between an optimum speed, maximum acceleration, but also the highest quality.
So the operator cannot do any mistake with the acceleration. I see. Wolfgang, we also add constantly new features to our machines. Can you explore on that?
Yes, Laszlo. By our own, but also together with a lot of partners, we did include or integrate and also develop a lot of special feeding solutions. This starts with multi-stick feeders, 120 millimeter feeder, which is actually our own product, tray feeders, feeders for axial or radial type components, or even pin header cutting feeders. And another feeder type which is quite often requested now are feeders for non-packed components, which is often called bowl or bulk feeder. And I have today an example with me. So this is a feeder from the company Mese. As I said, it's for non-packed components, in this case for small balls, ball diameter from around 0.2 to 0.8 millimeter. And the material of the balls can be different. This can be lead material. This can be, of course, also steel material. And we have also a customer which is feeding ceramic balls with this feeder to the machine. The feeder is quite compact, and beside this is also extremely quick. So this feeder, in combination with our CP20 P2 head, can reach a speed of up to 30,000 components per hour, which is really impressive. But feeding is definitely not everything. We do have also other features developed. One of the things which is quite new is the clinching tool. And if you like to know more about this clinching tool, then I would recommend to read our new white paper, which is available now.
Fantastic. All the solutions you have shown here, are they retrofittable? Are they open automation solutions?
Almost all things we mentioned are retrofittable. Many of the things we mentioned are software features, which can be easily retrofitted by a software upgrade or by a license, but also most of the hardware features can be upgraded in the field, yes.
Okay, friends, I just realized you have shown me cool options, but you just made things worse. The end-of-line machine is getting more workload and the bottleneck is getting worse. So what are you going to do about that?
Well, Laszlo, that might look like that, but in reality it's not. Why it's not? Because we have also enhanced the capabilities of the other heads in order to release the end-of-line machine. For instance, with the CP20 P2, we have increased the component range from previously 6 by 6 by 4, now up to 8.2 by 8.2 by 4. And that means now we can distribute components from the CPP head to the CP20 P2 head, but we have also enhanced the capabilities of the CPP head. Right, Wolfgang?
Yes, Jetula. We did enhance the capabilities, as you said. From the maximum placement force has increased from 10 to 15 Newton, the maximum component weight from 8 to 20 gram, and also the maximum height of the component has increased from 11.5 to 15.5 millimeter. But that is not all. We also have now grippers available for the CPP head. I took here also a sample with me. So here you can see the gripper, and here you can see the dedicated component for this one. It's a small shield. Like this, now components which had to be placed before by the twin head, because before only grippers were available for the twin head, can now be placed by the CPP head. And like this, we have again a nice line and head balancing.
So, and with these measures, Laszlo, now we can distribute components from the end-of-line machine, from the twin head, to the CPP head, and from the machine with the CPP head to the CP20, to the machine with the CP20 head.
So the complete line is now ideally balanced.
The line is still well balanced.
Thank you both for your expertise. Thanks for being with us. That was all for today, except for Some remarks. If you want to see ASMPT live, you can see us at one of the following events, which you see in the ticker below. Don't forget to download our white papers. Link is in the description of the show. Please also subscribe to the show and delight us with a thumbs up. We will be back in next month, and until that, have a nice day and stay open.